Alright guys, so we're going to do section 10.6, which if you read the book has some very good explanations in terms of this topic. It's probably one of the things I think the book explains pretty well. But we're going to go through it as well. I did not write the theorems down. I think they're wordy, and they don't necessarily convey the message I'm looking to get across here. Not that the theorems are wrong, but I think the examples do a better job of explaining it. So the first problem is when there's an angle inside the circle. So we have two chords that intersect in the circle, and they create an angle anywhere but the center point. If it's the center point, then the arc is equal to the angle it creates. But in this case, these angles are not the center point of the circle. So how do we find the arcs or the angles? And essentially what we do is we add up the two arcs that are created, arc AD and arc BC. We take an average of them. So you add them together and divide by 2, and that gives you your center angle. Linear pair is still in play here, and vertical angles still have to be congruent. So those theorems you learned previously don't disappear because we're inside a circle. But because we are inside a circle, we can find this angle by just averaging the two arcs. So for example, the average of 40 and 60 is 50. 40 plus 60 divided by 2 is 50, so angle 1 is 50. Therefore, this angle would be 130, and this angle here would be 50. The second one, let's say I give you the angle in one of the arcs, and you need to find the other arc. So 90 plus x divided by 2. So we're taking an average of the two arcs. So one arc will always be bigger than the angle. One arc will always be smaller than the angle. And we solve for x. We multiply both sides by 2. We get 150. You subtract 90 on both sides. And arc BC is 60 degrees. Excuse me. So that's how you find an arc when the angle's inside the circle. Now, when you have, let's actually skip ahead to this one. When you have a tangent line going through a chord such as this and creating an arc, like arc AB, the arc is going to be half, or the angle is going to be half the arc it creates. So arc AB, if you take half of that, would be angle 1. So in this case, if angle ABC is 50, arc AB is 100. If arc AB is 60, then angle ABC here would be 30 degrees. So the angle is half the arc that creates it. And then finally, when the angle's outside the circle, instead of adding the two arcs, we subtract and divide by 2. So we're not taking an average because we're subtracting. The bigger arc minus the smaller arc. So we always get a positive number up top. So in this case, 80 minus 20 divided by 2 is 30. So angle 1 is 30. 140 minus x equals, or divided by 2 equals 40. So once again, subtracting the arcs. And it doesn't matter if the arcs are created this way, with a tangent and then a secant line, or two tangent lines. We're still subtracting the two given arcs and dividing by 2 to get our angle. So here, 140 minus x divided by 2 equals 40. Multiply both sides by 2. We get 140 minus x equals 80. We subtract 140 on both sides, and we end up with a negative x equals negative 60. So x equals 60. So the arc here would be 60. Here we're just subtracting. 200 minus 160 is 40 divided by 2, which is 20. And angle 1 is equal to 20. So hopefully this video helps. And good luck.